My name is Denis홍, a professor in the Department of Mechanical and Aerospace Engineering and the founding director of RoMeLa, the Robotics and Mechanisms Laboratory at UCLA. Today, I would like to talk about some of the robot mobility technologies that we are developing and how the National Digital Twin can benefit from it and how robotics can benefit from the National Digital Twin. But first, I would like to start my talk sharing with you my recent experience at a simulated Mars exploration habitat. Named HI-SEAS, which stands for the Hawaii Space Exploration Analog and Simulation, is a Mars and Moon Exploration Analog Research Station operated by the International Moon-Based Alliance. Located approximately 8,200 feet above sea level, the HI-SEAS habitat is a 1,200 square foot dome located on a Mars-like site analog along the Mauna Loa mountain range on the Hawaii island. As you can see, there is really nothing green around, no plants nor animals. The terrain resembles that of Mars very closely, except for the color of the sky perhaps. Training astronauts stay here for 4 to 12 month duration for simulated missions. I was invited to join them, but luckily only for a few days. The simulated mission follows very closely to what it may be like on a real Mars mission. Once you enter the habitat, you stay there and can only come out through an airlock wearing a spacesuit. Because the gravity on Mars is only 40% of that on Earth, without exercise, you lose your bone and muscle quickly. So you get to exercise every day, which I normally do not, on Earth at least. You eat rehydrated freeze-dried food every single meal. You only have a very limited power and water quota. You get to use only one wet towel a day for washing up. Your bio-waste is recycled and reused, and you get to share the tiny space with your fellow astronauts. You get to know them very well, very quickly, including how they smell. Even communication with Earth, the outside world, is intentionally delayed 20 minutes to simulate that on Mars. Now, the real reason why I joined the mission was because our team at the robotics lab RoMeLa is currently developing robotic systems to be used in future Mars exploration missions. And I truly believe the only way to develop effective technologies is to personally experience the actual task and environment, well, as close as possible to the real thing, that is, and to interact and communicate with the people who will be using the technology that we developed. To make robots that can be truly useful on Mars, I had to experience the work and life on Mars myself. The environment in Mars is extremely treacherous. The atmosphere is 100 times thinner than Earth. Obviously, you cannot survive without a spacesuit. The gravity is about 62% less than on Earth. Well, sounds like fun, but this causes a lot of problems, including reduction of bone and muscle density, as I mentioned. It is freezing on Mars. The average temperature is minus 63 degrees Celsius and can go below minus 140 degrees Celsius. It is so far away, it will take years to complete the mission, which means that you will need to bring all the stuff needed for your stay, including food for consumption. You can grow food on Mars, but more on that later. And of course, the radiation is deadly. But one thing that concerned me the most that I was not aware until I joined the simulated mission was how dangerous the terrain is, especially around lava tubes. Lava tubes are cave-like geological formations created when molten lava cools down. The terrain around and inside it is like tens of thousands of sharp knives sticking out. Some surfaces are so thin and brittle, it feels like walking on fragile potato chips. And if you're unlucky, the surface below can collapse and you'll fall into the lava tube. That won't be good. Mars is a very dangerous place for sure. If life does exist on Mars, scientists say it would be inside one of such lava tubes. Lava tubes are also very important for the survival of the astronauts as it can be used as shelter against the deadly radiation. Thus, to explore such important areas, we want to deploy robots that can move around, climb off cliffs, crawl into lava tubes, and so on. We develop robots for the 3D applications, as you say it. Dull, dirty, and dangerous. Well, on Mars, not dull for sure, but dirty and dangerous, definitely. We would like the robots to enter the dangerous areas first to scan the environment and gather as much data as possible before humans enter the dangerous lava tubes. The robots would use LiDARs to gather 3D geometrical data of the environment, measure radiation and temperature gradients and visual information as well. All of these data will then use to create a digital map for robots and humans to utilize. But before we can gather such data, we need the robots to be able to get to the location of interest. This is why robot mobility is important. Okay, so let me show you some of the unique mobility robots that we're currently developing at RoMeLa. This is our latest project called Artemis, advanced robotic technology for enhanced mobility and improved stability. I believe this is the very first we're showing it to the general public. We have just finished the assembly of the lower body. These are some of our new actuators that we built for this robot called bear actuators. I'll probably skip some of these slides. We have just assembled the lower body and this is how it looks. And for the first time, I would like to show the motion of it. By the way, these are some of the things that we would like to do. A hyper dynamic motion. We already have the MPC controller and using motion capture data to generate the trajectories. And this is the lower body of Artemis, showing it to the general public for the very first time. So it has a wider range of motion than a human. And in our lab, it's about to take its very first step. I can't wait to show this to you when it starts running and jumping and doing all the exciting tasks. And this has been Artemis. So I have started this talk sharing with you my few days of experience at the simulated Mars habitat and exploration exercises. So what does this have to do with digital twins? Well, as a matter of fact, the Mars scenario I have just described is actually not too different from the concept of digital twins on a higher level. We develop robots with high mobility to access the difficult to reach areas to gather data. With such data, we build models of the environment so that we can run simulations and test things out before we send out human astronauts or before we deploy more robots. This model of the environment we build with such data, which may include information about the terrain geometry, chemical compositions, temperature gradients, radiation levels, etc., will help the robots not only plan ahead before the mission, but also will play a very important role for autonomous operations of the robots in real time. Robots will not only help gather the data for the model, but also significantly benefit from it in so many ways. And you can imagine what this new technology and infrastructure could do for us on Earth. And this is why I am excited about the National Digital Twin Project. Robotics is one of the fields that will not only contribute to the creation of the digital twins, but also one of the fields that will benefit most from it. Not only for Mars, but for us on Earth. Not only for robots, but for us humans, of course. It is truly an exciting time for us all. Thank you.